Hi, this is Sri Ramulu. So today's topic is Zener diode. Zener diode is a reverse bias heavily doped silicon PN junction diode which is operated in breakdown region. Right? So Zener diode is a reverse bias. It works in reverse bias, but it is heavily doped. Its doping level is higher. And here, which PN junction diode is they are using silicon. So generally diode in diode which material we use, either germanium or silicon. So but here we are giving more preference to the silicon only. Why it is given here below? Due to higher temperature current capability, silicon is preferred in composition to the germanium. Okay, so germanium cannot withstand at a higher temperature with a high current, so it easily damage. So but silicon it easily support to higher temperature and current capability, so that is why we use silicon instead of germanium. The symbol of Zener diode as shown in figure. This is similar to normal diode except a line representing the cathode is bent at both ends like the letter Z for Zener. So actually diode symbol is like this, but what they have done here, just this end bent like this and this end bent like this. So this appear to as a like a letter Z. So Z stands for Zener. The VI characteristics is shown in figure. It is obvious from the figure that as the reverse voltage applied to the PN junction is increased from 0, the current remains very small over a long range and increases very slightly with increasing bias. So it is obvious from figure. So there is one figure also given here. See here figure, it is a figure. It is given see like this. Okay. So it is see operating same as that of the junction diode. See here. It is obvious from figure that as the reverse voltage is applied to the PN junction is increased. Only we have to observe in reverse bias only, not in forward bias. So why? Because Zener diode works in reverse bias only, not in forward bias. Okay, so that is why here we have to speak about the reverse bias. Right? It is obvious from the figure that that as the reverse voltage applied to PN junction is increased from zero value to we are increasing, the current remains very small over a long range and increases very slightly with increasing bias. Here what they are saying, at the beginning if you increase the voltage, reverse voltage, current also increases but very small current. For a long value of voltage, what happens then, it is also slowly increases. Okay, but when the reverse is made very high, covalent bond near the junction breaks down. So generally junction how does form? It is a p type, n type. Here junction will form. So when reverse voltage is applying, then so covalent bonds near to the junction starts breaking down. Now the reverse current increases Zener voltage. In this region of characteristics, voltage is called breakdown voltage or remains constant over a long range of current. So here voltage generally when we increase the voltage, so current also increases slowly, but at a particular voltage current increases sharply in reverse direction. Hence diode may be used to stabilize the voltage. So that means at a particular voltage only current increases maximum. Later if you change the voltage, it cannot change anything. There are the two mechanisms of breakdown. What are those? Zener breakdown, and next one is avalanche breakdown. What is a Zener breakdown first? Zener breakdown takes place in very thin junction, that is when both sides of junctions are very heavily doped and consequently depletion layer is narrow. Right? So it is like this, p type, n-type. So this is heavily doped and it is also heavily doped. Then this region is very thin. When a small reverse bias voltage is applied, very strong electric field is set up across the thin depletion layer. So when we apply the small voltage, then electric field establishes, isn't it? Strong electric field established across the junction. This field is enough to break the covalent bond, and now extremely large number of electrons and holes are produced, which constitute reverse saturation current. So here large number of electrons and holes pair generated, and then these large number of electrons can constitute large current. So that is why the breakdown region will occur. So that is like this. Next, Zener current is independent of applied voltage and depends only on external resistance. So up to here only it depends on the voltage, up to here only, and later it cannot depend. So that is why it is a voltage regulator. How much voltage you apply, it takes a certain amount of voltage only, later it cannot take more than this voltage. That is a Zener breakdown. Next, avalanche breakdown. This type of breakdown takes place when both sides of junctions are lightly doped. So Zener breakdown is heavily doped. So avalanche breakdown is lightly doped, right? P region and N regions are lightly doped, and consequently depletion layer is large. When lightly doped, this region very much large, right? This region. In this case, electric field across the depletion layer is not so strong to produce Zener breakdown, isn't it? So in this because of this, electric field cannot work here. Then what will work? So in above electric, because of electric field only covalent bonds are broken. But here minority carriers accelerated by this field. Okay, because of that field, minority carriers means in p-type material and n-type material. P-type material minority are electrons, n-type materials minority are holes. So these electrons and holes are accelerated because of that field only with the semiconductor atom in the depletion region. Due to the collision, and they start colliding, accelerated by the field, then they collide with the semiconductor atom. Okay, in the depletion region, semiconductor with the semiconductor atom, they collides. Due to this collision with the valence electrons, covalent bonds are broken and electron hole pair are generated. Like this here, electron hole pair generated here because of collision in avalanche. In Zener breakdown, because of electric field only. These new carriers so produce acquired energy from applied potential and in turns produce additional carriers. Again they produce. So these generated electrons again collide with the other atoms. Again they produce one more electron hole pair. The breakdown is called avalanche breakdown and it is shown in figure. In figure also it is shown. So this is avalanche breakdown. See, avalanche breakdown, it is Zener breakdown. At a Zener voltage, at a reverse voltage less than 6 volts, Zener breakdown predominates, while at about 8 volts, avalanche breakdown predominates. So that means Zener breakdown works at 6 voltage and avalanche breakdown works at 8 volts. So that is the meaning of this. Okay friends, thank you.